You're listening to World Oil's Deep Dive, where you'll get to know the authors of technical articles in World Oil magazine and learn more about their company's technology and how it's shaping our industry. Now, here's your host, Jim Watkins.
All right, welcome back, everybody. We're continuing our live from the Hydraulic Fracturing Technology Conference here in the Woodlands series. And now we're recording at Kirby Ice House, where Universal Pressure Pumping is having their client event tonight. And so we have a couple of very special guests to talk about some recent developments at Universal Pressure Pumping, and we'll get right to it. So, Cam, Jesse?
Yes, sir.
Why don't you guys introduce yourself to everybody first? Give your title, what you do, talk about, what you're working on there at Universal.
Yeah, so my name's Cam Hornor. I've been at Universal for about 5 years now. I'm a technical service advisor. I started in the field with Universal in the Northeast, transferred down to Texas a couple of years ago, and joined the technical services, or now the solutions group with Universal, and we work on a multitude of different projects throughout the company, things in operations as well as sales, business development, and sometimes even product development. So,
oh wow, they drag you in on everything.
Yeah, it's nice. You get to kind of touch on a lot of different things.
Swiss Army knife.
Swiss Army knife.
Yeah, exactly. So it's a fun position to be in, but you get a lot of exposure to different parts of the company. So it's
That's
nice.
fun, right? I mean, because
absolutely.
you get to touch so many different parts. It's not boring. It's not repetitive in that respect, right?
Yeah. Every day is new and different. So it's really a great position to be in.
Awesome. And Jesse, what about yourself?
So same for me. I've been with Universal for about 10 years now. Started up in the Northeast and held different field engineering, operational, in-house engineering roles up in the Northeast. Transferred down to Midland in 2020 to help start our technical services division. And part of that was bringing Cam and another gentleman on board about 6-8 months ago. And I've recently transferred into the business development role at the beginning of this year. Awesome.
So, wow, that's quite a thing to say. Hey, I started up this group, right? Is that like did you get a badge or something you get to wear? Or does that what? How does that work?
Usually a crown. I wear a crown around the office, but yeah. So that was an initiative that we started. A COVID initiative was let's drive our technical teams and at the time we didn't have a technical services division and we got headed up by a gentleman in Houston, and I was based in Midland. I had a couple counterparts up in the Northeast, and we really just, we didn't want to be part of sales. We were part of Universal, so we helped drive new technologies and stuff like Cam said. We were integrated into every portion of Universal.
Wow, that's impressive. And we're here today to talk about your award-winning technology, right? I mean, the friction reducers and recycling produced water, right? That's what we're talking about.
Yeah. So recently I wrote a paper a handful of months ago that was nominated for a World Oil Award in Best
Did
Water.
you win? Wait, did you win?
Next year. Yeah, we're going to win next year. But I did not. No, not this time. But it was nominated, and we were really happy about that. But what it was it was a way for us to work with our customers. We developed this technology to optimize the amount of produced water used, reduce fresh water by really looking at the chemistry that we use. Friction reducers are really, they get degraded pretty easly by the amount of total dissolved solids in the water. So using any sort of measurable amounts of produced water will really degrade those friction reducer. And we need high quality friction reducers there's a lot of tubing friction when we're pumping at high rates down these wells. So by using pre-job water analysis, looking at the multitude of friction reducers that we have in our product lines, we could tell the customer, hey, you can run as much produced water as you want, because now we have these friction reducers in our product line to be able to meet the demand, to keep up with these crappy waters, really.
Right. Yeah. Well, that's interesting because that area, right, the whole idea of reducing TDS, period, right, and how much can be in there, before you can use it for recycling and things. I think for me, that's a very interesting part because there's a lot of the whole water recycling idea that's built around that, right? So for somebody who's not a chemistry guy, right?
Yeah.
Can you explain to me how you could change a friction reducer to not be affected so much by TDS?
It's
or is it too complex?
Not a chemistry. We have a domain champion for chemistry that is the man, in my opinion, in our company, in our industry. But really it just comes down to we don't manufacture our own friction reducers,
right?
But we rely on our vendors to be bringing these products to us all the time, and for us to be doing our due diligence to test these, to bring to make sure we are giving our customers the best friction reducer at the best cost. And it may be the most expensive friction reducer on the market, but if you can use it and run a lot more produced water, and then you can use it at half to 3/4 less than what you would run of a typical friction reducer, in the end, on a per barrel of treated fluid, it is significantly cheaper to run the higher quality product.
Yeah, because it's all about ROI, right? It doesn't matter if it's crazy expensive as long as you're making
it may
up for
be
it,
expensive on a per gallon basis, but if you can run a half a gallon per 1,000 gallons of treated fluid, now you just brought that cost down to half. Whereas a lower quality product you have to run so much more of. So that also brings in the ESG. Not only just reducing the amount of water, but if we can reduce the amount of chemistry that we're actually putting on site, that equates to less trucks on the road of delivering these loads of FR, fuel burn. There's a handful of things that we've tied into. It doesn't seem super technical, but it's we've tied in these different calculations to optimize the proper chemistry used on site.
Right, and when you're talking about ESG type things, for me, the ability for us in our industry to use produced water and reuse it instead of going to fresh, right?
Yep.
And some places there's a lot of fresh, but some places there's not, right?
Yep.
So, to be able to do that in a cost-effective manner makes a huge difference in that ESG equation, right? For operators and people, they're like, hey, wait a second, we're not going out and buying fresh now. We're just putting it back down whole again. So on that, then, so at what point, so the FRs get introduced before it goes through, they're getting fed in before it gets pumped down, right?
Correct. Yep. We inject the friction reducer on site. So produced water comes to the site, it goes into tanks, and then it goes through our equipment. We pump it downhole. When it meets the blender where the sand meets, we also inject our FR there, and that's where it mixes with the water and reduces that friction pressure significantly. We're seeing anywhere up to 80 to 82% reduction in friction.
82%.
And if we did not have proper friction reducers, you cannot treat a well.
Oh,
at the
absolutely.
Rates that
Yeah. You can't pump it that fast. Do you want to give a shout out to your supplier? Who is that?
So luckily,
or maybe not.
Luckily for us, we have a handful of suppliers. Great suppliers out there, and there's a lot of chemistry suppliers, and we enjoy working with all of them, and like we do for our customers, they do for us. They bring us different products and say, hey, test this one. We've changed, we altered this one slightly. Can we test it out? And we do our diligence to make sure that we are putting those on site or testing them in the lab to solidify the fact that what they're saying. But then we're also going to our customers to make sure, hey, we just got product A, we can run significantly less of it. With that, it's going to be a cost savings for you. You can do X, Y, and Z now because we have this in our product line.
Right, exactly. And so going back to the mechanics of it then, so how are you making sure that the dosage is right for the TDS of the water? I mean, that's getting measured coming in before you put the chemicals into it before it gets pumped back down.
Right. So what we do on the pre-job part of it is we actually get the water quality that we're going to be pumping before we actually go to the job. Take it to our lab, whether it's in Midland, Texas or Pennsylvania. Test that water, see how bad it is, how good it is. And then at that point, we have done thousands of friction or of flow loop tests, which is the measurement of pressure drop, prior to friction reducer being added. And we have done so many of those that we we know which products are going to work.
Nice.
And then we take that friction reduction and output it into where it started was we were just taking this friction reduction percentage and looking at it at a pressure per 1,000 foot of pipe. Where we went further was now we started to we took other hydraulic calculations to be able to output estimated treatment pressures, surface pressures, along with what kind of rates we'll be able to achieve based on the casing that we were in. And that was one of our variables was, the friction reduction percentage. And what Cam wrote about was now we are so honed in on, we know which friction reducer is going to produce the best outputs, and we're going to put that friction reducer on site, that we took that out of being a variable, and Cam put some different variables as far as casing designs, and he can talk about because that was we played off each other with what we were going to do there.
Yeah, exactly, and I understand that some of the work that Jesse was doing was integral for you figuring out, okay, this is how the casing affects that, right?
Yeah, absolutely. Jesse's being a little humble. When he was writing this paper,
that's what they always say about Jesse. He's always humble, right?
It paralleled with the development of a tool or a program that we use basically every day, especially in our group in particular. That really has a lot of variable inputs, and when he was working on his paper and his projects and his customer ideas and developments, the main focus on that was the chemicals, the FR, and like you said, we do the testing, and then what are those FRs in that water testing, and what do those percentage efficiency reduction percentages look like? That was the main input and focus of the tool that he developed.
Right.
And it gave us a lot of outputs, in terms of max achievable rate, pressure at max achievable rate, max pressures if max rate was unachievable. It even broke down costs and things like that. And one of the most valuable things it did was gave a pressure variance chart at the end, which basically showed us, what we estimated, through all the hydraulic calculations, through all the process, what we estimated based on, all the well inputs that were kind of, standards or whatever was going to stay the same. What did we think each stage was going to treat at, and then what did it actually treat at?
Oh, interesting, yeah.
So, that was an initial development on his initial tool. And, in the last year or so, when we were utilizing that tool kind of post-frac, we noticed, hey, what if we, instead of focusing on chemicals being the factor that is changing, let's make it a constant and look at wells that do have a large pressure variance. Why do we say that this well should, hit max achievable rate on stage 2, but it's not hitting it until stage 22?
Oh, interesting. Yeah.
Right. So we were like, okay, well, how can we move that backwards? What can we look at? And so we basically took Jesse's initial tool, which was chemically based, and turned it to more of a pressure variance tool. And the idea was that, you would take the constants like chemicals and make it a constant, and then you would use, estimated ISDPs and obviously your well lateral length, perf design, things like that. That would all stay the same. But one of the main things that you could look at was casing designs. How did different casings, whether it's a single string, tapered string, affect the different pressure variances that came about? And what we found is, of all the variables that you could change, casing obviously was the most impactful.
Really?
Perf design, obviously there is some changes, but I don't want to call it negligible, but significantly less than something like casing, even in terms of, rate or pressure maxes and things like that. So what we wanted to do with that was show our customers, they're obviously aware of that. They're aware that these casings have restrictions, whether it's a max pressure or a max rate or something like that. But what we wanted to do was show them, hey, we know you guys are aware that you're pumping at a reduced rate, but what is that costing you time-wise, right? What is that costing you efficiency-wise?
Right. Yep.
So, if you were doing a 5.5 single string but not hitting max rate until halfway through the well, what if we, did a tapered string with 7-inch into a 5.5 or maybe a 4.5, get some tubing, friction reduction or something like that. What does that mean for our timeline, our efficiencies on pad,
That's crazy. So you can actually measure that. You can quantify that. You can say, like, look, if you did it this way, you'd save this much time.
Absolutely. I mean,
wow.
That's the idea of it.
Right. Yeah, exactly.
In theory, yeah. But, for the most part, it seems to check out because on good wells, what we really do is take, if we predict it and the actual is right on top of it, it's good. It's a good fact check for us,
Yeah.
Because we work with a lot of different customers. They do a lot of different casing designs, so it's really helpful to be able to little checks and balances for us. But what we want to do is basically take the ones where we had large pressure variances, go to them, and be like, hey, this well took an extra 4 days because of your rate reduction over, let's just call it 40 stages, right?
Right.
Well,
yeah.
what would happen if the casing design was, X, and you were able to hit max achievable rate and stay under max pressure starting off from stage 1, right? What cost savings and efficiencies would you see? And that was the main thing we wanted to bring forward to customers.
That's interesting. Do they heed that advice, like going forward? Because you're getting this off of one well, and maybe they're working another pad over there, and they're getting ready to put it down, right? And they're like, oh, shoot, man, let's do it this way because we're going to get a better rate. We're going to save this much money if now we use this knowledge that we have.
Yeah, I would say some definitely are a lot more, a lot more receptive than others, maybe, to listening to it. But when you really put numbers and costs behind it, they perk up a little bit and really start paying attention, which is nice. But when you bring this information to them too, and we talked about this in the paper, they were aware of it. But what a customer actually did was they wanted to say, hey, we want to actually increase our rate by 20%. Can we do that, right?
Yeah.
What are we going to have a drastic effect on our timeline, or can we even do it? Period. With our current casing design, these wells have obviously already been drilled.
Right.
You're not going to go in and change them. You're not going to make them larger or smaller at this point in time. But they, for whatever reason, wanted to change up their frac design, do a 20% increase in rate, and they came to us and they're like, we know this is something you guys do. This is something you look at. Can you, quantify and show us if this is possible, or if it, it's not possible at a max rate? What is our increased cost variability going to be? So
interesting.
Yeah,
that's interesting. So, I mean, can you end up helping them? I mean, because that means you guys are working like hand in hand, right? Because it'd be like, okay, well, show me your well design, show me your casing design, and then obviously then kick it over to Jesse. Jesse's like, okay, well, if we use these chemicals, then we can change it by this much, right? I mean,
yeah, and that's the whole point of the technical services group, is to work with our customers as trusted partners. So don't tell our bosses this, but we go to our customers to try and help them out. Obviously, at some point, it's going to help us out as well. But our initial thought is, hey, let's drive better business for them, because if we can help them drive better business, it's going to drive better business for us.
Oh, absolutely.
So
that's the key, right?
Yep,
in
right.
all relationships, man, you want to give as much as you possibly can, and people understand that, man, and more business comes your way. Unfortunately, in our business, that's like secret sauce to some people. Though they're like, shh, don't tell anybody else, man, that we're doing this, right? Because we're getting faster rates and everything. So
we've done this with a lot of most of our customers, and the other output that Cam kind of talked about was a comparison of pre-job versus post-job. So we're generating these end-of-job variance reports that Cam and our other tech services group has come up with, but it just shows, hey, we were supposed to treat at 100 barrel per minute. We only treated 80% of stages at that 100 barrel per minute. What was the outlier of these 20% of stages? Was it rock? Was it something in the rock? Was it X, Y, Z? What caused these reduction in rates? And that's something that then we can take to them and we can have discussions on, rather than, hey, we didn't get the rate. What's going on? Let's figure this out as a team.
Yeah. Right. Yeah. And I suppose, every client would love that, right? They want to know, they're not going to be happy if they're not hitting the rates they thought they were going to hit.
Yeah.
But understanding why that is, and getting your head around that so that you can change it for the future or make adjustments in chemicals or whatever.
And time. These operators are tied up with so many other things that if we can just take our time to point some of these anomalies out and say, hey, what was going on here? They may not have even looked at it.
Really?
Hey, the job was pumped. We're done with it. Cool. But if we can take our time and take that off of their plate and say, by the way, we had X amount of stages that didn't hit this rate or this pressure, or we didn't pump all the sand, whatever it may be. Like, once again, now they trust us to be looking at their data prior to them looking at their data if they don't have the time to do it.
Right, and that is awesome because everybody's strapped, right?
Yeah.
I mean,
Yes.
nobody has time, right? I mean, they're like, it's funny because you would think with all the digital advances and everything that there would just be like some report that gets spit out. It's like, here you go, this is what happened, but not always the case, right?
Yeah.
They got to dig into the data themselves, and it's like, who's got time for that, man? We're on to the next well. We got to do that, right?
Yeah.
Right.
So no, that's impressive, man, and that's interesting because I get to talk to quite a few folks at Universal, and no one from the technical service side. I mean, to be able to do that, so that's an important part of the whole puzzle when it comes to pressure pumping, right?
Yep.
Yeah, it's really nice. It's low pressure. It's not quite like sales where you feel like you have to go in there and make the deal happen. You really
Right.
just want to go in there and be a benefit to the customer on things that I'm sure they would like to have the time to look at. But like you said, everybody is pressed on time with whatever they have to get done in the day. So I think the ones that do appreciate us coming in and showing some data and showing some analytics on potential improvements for the future, they do appreciate. So that's what our group's around. Centered around is trying to take some time off their plate for things that might be important to them.
So who actually goes out and talks to the client about that? Is that you guys together as a team, or one or the other? Or?
Yeah, that's really what we try to do. We try to get, now being on the sales side,
Right.
The goal is, hey, every time we go meet with the customer, depending on the situation, let's take a technical guy because there may be something that they want to chit chat about that. Once again, it just adds value to Universal, adds value to our customer.
Right. Yeah. No, that's interesting to me. So when you show them this data, this may be digging a little too far. Tell me if it is. But have you ever had anybody go like, "Wow, that's super interesting or important," or what's their reaction? Are they just like, "Whatever, man, just let me go"? I mean.
Yeah, so one of our most recent ones, which was really, it was super interesting for us because it was kind of like when we first kicked off this project and really looking at it in depth with some wells that were really abnormal in
Right.
treating, I guess. We spent a lot of time, did a lot of analytics, and had this really good presentation, wanted to got in front of the customer, presented it, and at the end of it, they're like, we've been doing this on our end as well, and basically everything you're saying aligns exactly
Wow.
with what we're looking at, just coming from two totally different ways of looking at it. But the end result of the conclusion we both came to matched up almost directly. So it was interesting to see that. And what snowballed after that was continued work, and we've even brought in some other resources to help us to help them in evaluating this. And honestly, I believe at this point they have changed some things in their casing programs now. I think so that they've at least on 2 to 3 wells have made adjustments or changes in their casing structure, and as well as some frac changes. So
Nice. That's amazing. But was that shocking to you that they were like, "Hey, man, we've been looking at this too," or is that the usual thing?
No, I'd say it was more of a relief than a shock. I mean, it's nice to see that. It's nice to see that what we were looking at was on par with what they found important.
Yeah.
You know what I mean? And
Yeah.
I mean, like I said, time is money, or so if we're talking about 5 to 10 days extra because you're at a reduced rate and you're talking a 3 or 4 well pad, if you're
That slows down everything. Yeah,
right. And
yeah.
the main thing was they were going to plan to be in this area, this basin for a while, so they wanted these were almost the kickoff wells for
Right.
this the part of that year, and they were trying to get a resolution quickly. And at this point, honestly, we haven't done a ton of work on it since because it kind of lined out
Right, exactly.
in terms
exactly.
of the issues. So
And so they took that under advisement, made the changes, and now they're flowing. It's happy.
yeah, like I said, also we've put in some third-party resources as well because we kind of zeroed in on what we actually might think the issue was.
Right.
You can only go so far with casing, right? If it's already in the ground, then what else can you do? Maybe
Right.
it's a lithology issue, whatever it might be. And we got ahead of some of the casing things, and then we were able to get into some of the design things in terms of what might the lithology, which we think is kind of like the source problems. you know?
Right.
Fixing the casing is just it's just kind of a workaround fix to
Right.
what the actual problem, which is we believe the lithology of it, which is a whole other rabbit hole in somebody else's paper.
Yeah.
Well, guys, that was an interesting conversation, and it's fascinating to hear from you guys. You're part of what you're doing for Universal, and I think you're really contributing to the overall customer satisfaction and all of that that goes along with partnering with Universal on these jobs. I mean, it's interesting to me from the outside, a guy who has no dog in the fight, but to see why would somebody choose one company over another to do that? And I think it's those type of extra service things that make a big difference,
Yep.
right?
Absolutely.
And it really cements those relationships. So thanks a lot for being on the show, guys.
Appreciate it, Jim.
Great, Jess.
Yeah.
And hey, let's go drink some beers, huh?
Hey, we're ready to go.
There we are.
Absolutely.
All right. Thanks.
Appreciate it.
Thanks for listening. Take a look at today's show notes for links we mentioned in the podcast. We enjoy your feedback, so if you have any questions or comments, email them to deepdive@worldoil.com. Check out worldoil.com for the best oil and gas industry technical articles and news. And join us next time for another Deep Dive with World Oil.